Hello, everyone. Today, let we discuss about a quicksort algorithm, lab set 4. As you all know that like quicksort, okay, any sorting algorithm, quicksort, merge sort, whatever it may be, what exactly it does, the unsorted data elements will be sorted in what ascending order or descending order. The unsorted array will be sorted in a ascending or descending order. And normally, the quick sort algorithm, whatever it is there, it uses what technology? Divide and conquer method. So normally what happens is whatever the array elements you give, the array elements will be divided, or the complete array, whatever it is there, it is divided into sub arrays. Means you're partitioning, you're dividing. So once you're dividing it into multiple sub arrays, then you're conquering it, then you're combining it for what? Then you're combining it to form a sorted array. That's it. The simple thing, what exactly you're doing is large problem is divided into small problem and combined together to get what? The sorted array. And the basic funda, how exactly the quick sort will work. So you need to take a array elements of n elements, whatever it may be there. So in that, what happens is you're choosing one element as a pivot element. And whenever choosing one element as a pivot, it can be chosen the first element as a pivot element, or the middle element, or the last element. But in our algorithm, we are taking the first element as what? The pivot element. Okay. So then what we are doing is we are calling your partition function. So whenever we call your partition function, the array, whatever it is there, it will be divided into two halves. And here what exactly happens is once the array has been divided into two sections, the pivot element, whatever it is there, that will be placed at the correct position. Means wherever it has to be there, it is going to place at the correct position. And what you can say is the elements towards left, whatever it is, left to your pivot element, whatever it is there, it will be lesser than your pivot element. And the elements that is right of whatever it is there, that will be what? That will be greater than what your pivot element. Means pivot element will be placed in the right position. Elements towards left will be lesser than pivot. Elements towards right will be what? Greater than pivot element. And again you're calling what? Two subarrays are there. Again you're calling sort partition function for this left subarray and this right subarray. Means here what happens is the subarrays, whatever it is there, are sorted separately. Again what you're doing is you're calling quicksort algorithm recursively. You're calling the quicksort algorithm recursively. That's it. Hope you're clear with this, how exactly it works. So here what exactly you're doing is, as I said that the first element will be taken as what? The pivot element. And here you're taking two variables, I and j, where I will be pointing to your second element and the j will be pointing to the last element. The j will be pointing to which one? Yeah, the last element. And what exactly you're doing is increment your I value or I index until you find the element that is greater than or equal to what? Pivot element. Means I will be pointing to the second element. So you keep on incrementing your I value until what? Until you find the element is larger than or equal to pivot element. Why? Because whenever you partition into two halves, the left side, whatever it is, it will be lesser elements than your pivot element. That's why keep on incrementing your I value until what? Until you find the element that is larger than or equal to what? Pivot. So whenever you find, you stop. And next, you go with your j. So j will be pointing to which one here? The last element, high. So what you're doing is you're decrementing your j value until what? Until you find the element that is lesser than your pivot element. Until you find lesser element, you keep on decrementing your j. That's it. So I move towards right and j move towards what? Left. That's it. And after doing that, whenever I is being incremented until you find the larger element or equal element to your pivot, j will be decremented to until what? Until you find the element lesser than pivot. And after doing that, you stop and you're checking the index of your I and j. And if your I index is less than your J index, then what you're doing is you're swapping A of I array with what? A of J array. Or if your J index crosses your I index, J index crosses your I index, whenever this becomes false, what exactly you need to do is you need to partition. Means you're swapping between what? You're swapping between the J index with your pivot element. You're swapping what? The J index with what? Your pivot element. And the J position, whatever it is there, that is the partition method, or the pivot element will be placed at the right position. After doing that, again it has been called recursively. So this is how exactly how your quicksort will go. Hope you're clear with this. Okay, so coming here, I said that for your sort function you're passing three parameters, namely the array elements, and two variables you need. One is your low and one is your high. And as you know that low is nothing but your I index, high is nothing but your J index. So why you use this loop while low is less than I means if there are more than one element, you need to compare, right? That's if I and J both pointing to the same element, then no comparison. It is already sorted. Hope you are clear. So this is recursively. So you are going to call your partition function. Once partition function is called, you're getting two subarrays, two what you can say is arrays you'll get. So for that you need to call for your left subarray as well as your right subarray. For your left subarray, what do you need to do? So it starts from the A array you need to take, and low will pointing to the I index, and S minus 1. So before the element of your which one? Pivot. So you're returning this partition function to your J pointer. J pointer. A J pointer is something about your pivot element. And the left towards whatever it is your pivot element, this is all your left partition. Towards right of your J, whatever pivot element, whatever it is, that's your right partition. So that's why A low S minus 1. Pivot element before that. That's your left partition. And right partition, pivot element plus 1 means J plus 1 to what? I. That will become what? The right partition. So this is recursively it calls. That's it. Hope you're clear with this. And coming back here, what exactly your program, how exactly it works. Let me take an example. After that, let me go with your program, how it is it. So here, I've taken totally how many elements here? I've taken 6 elements, array size of n equal to 6. Okay, means total 7 elements are there. And as you know that pivot element, whatever it is there, it will be pointing to what? It will be pointing to the first element. And I need two arguments for your sort function. That is your low and high. Low is pointing to what? That is your I index. That is low plus 1. Means low here it is a 0. Low plus 1 means it comes here. And J index will be pointing to the high, means the last value. So your J value is what? High. So I and J are that particular position. And pivot element is what? Your first element, that is your low. Hope you are clear with this. Okay. And now what you are doing is, as you know that you are comparing, while low is less than high. Means if there are multiple elements, yeah. Low index is what? 1. J index is, high index is what? 6. 1 less than 6. Yeah, you can perform the operation. What you're doing, A of I. Okay, A of I is what? 20 is less than equal to pivot. Yes, 20 is less than equal to pivot, and I is less than S. Why you'll check with this? So I doesn't cross your end element. I doesn't cross your element. If it I reaches here, no more elements are there. So until it reaches this position, you keep on, you can increment. That's what they are checking. So I said that increment your I value until what? Until you find the element that is larger than or equal to pivot element. 20 is less than 45, false. So that's true. Then what you'll do? 35 is less than 45, true. 10 is less than 45, true. Increment I. So you keep on incrementing I. See, while A of I is less than equal to pivot and I is less than H, increment I. So 20 is less than equal to 45, yes. 1 is less than 6, true. I will be incremented, it becomes 2, comes to your second index. Next 35 is less than equal to 45 and 2 is less than 6, yeah, true. Increment I, it comes here. Next 10, 10 less than equal to 45 and 3 index less than 6, yes, true. Increment I will come here. 60 is less than equal to 45, it becomes false. At that time, what happens is I index will pointing to which one here? Fourth one. Okay. Next, what you need to do? You need to check with else loop. Okay, A of J is greater than pivot element or not. I said decrement your pivot element until you find what? Less element than what your pivot. 15 is greater than 45? No, it becomes false. Stop. So where will be your I and j? I is here, j is here. So I am checking if I less than j. I need to check, right, the index. So 4 less than 6, yeah, true. Then what I need to do? I need to swap these two things. I need to swap these two things. So here you can just check it out. So here I is here, j is here. So it be now it stops. You'll check I index is what? 4. 4 less than 6. Yes, true. Then I need to swap. So 15 will come here, 60 will go here. That's it. And I and j pointer will be pointing to the same position. Next, I'll repeat the same thing. While low is less than high, means what? 4 less than 6 is true. Then a of I is what? 15. 15 is less than equal to 45. 15 is less than equal to 45. S true, it comes here. Next, 55 is less than equal to 45. False. Stop incrementing your I. Next, you check your j value. A of j, 60 is greater than 45. Yes, decrement j. 55 is greater than 45. Yes, true. Decrement j. Then whenever j index crosses your a index, what do you need to? Swap your j index value, a of j, with what? Pivot element. That's what, see. Now I is what? I is 5, j is what? 4. So 5 is less than 4 becomes false. Then what do you need to do? Swap your a of j index with what? Pivot element. So next 15 and 45 will be swapped. And so this is what? 45. So whenever you partition the pivot element, see, 45 is placed at the right position. So the elements towards left, whatever it is, that will be lesser than what? Pivot element. Okay? 10, 35, 20, 15, all are less than that pivot element. And all the elements towards right will be what? Greater than pivot element. That's it. And you get left subarray and right subarray. And this your j pointer will be pointing here. The left subarray will be what? A array, low pointing to the same thing. I will pointing to your low, and j will be pointing to which one? I will be pointing to what? J minus 1. For your right subarray, I is pointing to the same thing. This will become low, and this also low, whatever it is, what it is, j plus 1. So j plus 1 will become low, and h will be pointing here. That's it. So this will become right subarray, and this will become what? Left subarray. And again, I'll initialize pivot element to which one? 15. And this is your I, and this is your j. I is your first element, low plus 1, and this high will be what? Your j minus 1. So it will be pointing here. So I'll check. A of I is what? 10. 10 less than 15. Yes, true. Increment I. 35 less than 15. It becomes false. Stop incrementing I. Check with your 20. 20 greater than 15. Yes. Decrement j. 35 greater than 15. Yes, true. Decrement j. 10 greater than 15 becomes false. Stop. Whenever j index crosses your I index. So j index is what? 1. I index is what? 2. Yeah. 2 less than 1 becomes false. Then what do you need to do? Swap your j, a of j, with what? Pivot element. So 10 is swapped. Okay, then 15. So whenever you partition, whenever you swap your pivot element, so that then what happens is you will get two subarrays, left subarray and right subarray. Now you check it out here. Here, this is your pivot element. It was there, and I and h, that is low and I, both pointing here itself. Low and h will be pointing to the same element. So here you check it out. 0 less than 0, false. That means it's already sorted. That's it. Right subarray. Here this is your pivot element, and I is what? Low plus 1. J is equal to what? I. Okay. So next what you will do is here 35 and 20 is there. So now we will check. 20 is less than 35. Yes, true. And I is less than h. Means this is index is what? So 3 is less than 3 becomes false. 3 less than 3 becomes false. So at that time what happens is you need to swap this and this. Okay. It is your 20 and 35. J index is here. J and this is swap. So next it becomes what? 20 and 35. That's what's here. 20 less than 35. It is 20 less than 35. It is what? True. But I less than j. So the I less than what here? H, whatever it is. That is 3 less than 3 becomes what? False. Then 20 is greater than 35. No, false. Then you'll check 3 less than 3, false. So swap what? A of j and A of pivot. Means 20 and 35 will be swapped. And coming to your, see, 10, 15, 20, 30, 45, all is sorted. Now I'll check with your 55 and 60. So pivot element is 55. And I and j both pointing to which one? Here? 6. You'll check now. A of I is what? 60. 60 is less than 55. 60 is less than 55. No, false. Okay, and you'll check 60 is greater than 55. Yes, other than what happens is decrement your j value. Then you'll check j is pointing to which index 5, I is pointing to index which one, 6. So 6 is less than 5 becomes false. Then what you need to do, swap your which one. So j is also pointing to the same thing, pivot element is also same thing. Swap this thing means 55 55 55 60 it will be, that's it. So 55 and 55, so swap both the things, it will be in the same position. And then you get what, the sorted array. Then you get what, your sorted array. Hope you're clear with this, guys. The simple thing how algorithm will work is, so take first element as pivot element, and check, compare, I value will be what, your low plus 1, j value will be a high. Increment your I value until you find what, the element that is greater than or equal to which one, your pivot. Keep on increment. Whenever you find greater element, you stop, and decrement your j value until what, until you find the smaller element. And then you check the index of your I and j. And if your I index is less than j index, swap a of I and a of j. Or if j index crosses your I index, then what you need to do is, you need to swap your a of j with what, pivot element. Then you get what, the pivot element will be placed at the right position. Then you get left subarray and right subarray. And you need to return that particular pointer where the pivot element is. And the left subarray will be what, j minus 1. And the right subarray, what happens is, the low will be what, j plus 1 comma high. That's it. Hope you're clear with this. So how exactly this works. And now coming to your question, they said that, oh, what is the question? Sort a given set of n integers elements using what, quick sort method, and computes its time complexity there. You need to check how much time it takes for sorting. Run the program for varied values when n is greater than 5000. Means n value whatever it is greater than 5000, you can give the set, and record the time taken to sort. How much time it takes for sort, I need to check. And they said that plot the graph for what, for how much time it has taken versus what, the number of elements. You just read 4 to 5 elements and plot the graph versus element versus what your time. And they said that whatever the elements you're taking for your sorting, the elements either it can be read from your file, or it can be generated by what, by using a random number generator. And demonstrate using what they said is how Java program by using your divide and conquer method as well. And we'll go with what exactly the main aim of your program. So you can just see here, the aim of this program is to sort n randomly generated elements. You need to use your random class to generate what, random numbers, okay, using quick sort. And you need to plot the graph for what, the time taken to sort n elements. And how exactly you are implementing, call a function to generate a list of random numbers. Means you need to call a random class that is going to generate some random integers. Okay, after that you need to record your clock time before sorting, and after sorting you need to record your again, see they said call quicksort function to sort randomly generated elements. Again record your clock time after sorting, and measure the difference between what, the completed time, stop time, and start time, that you'll get the elapsed time, means how much time it has taken for your sort. And print the sorted in elements and time taken to sort that. So this is how exactly you need to write your program, how exactly it is implemented. And here what you're doing is, as you are using your random class to generate random numbers, so for that what happens is, how exactly the class random can be created. So random class name, and this is used for random object, it can be anything, rand we have given. And observe, random r should be in uppercase, equal to new keyword, okay. And this is what, random with this parenthesis, this is called as constructor, that is used to initialize the object. And here how exactly you can invoke the random numbers by using your rand object. So this can be anything. So you can use a method called as nextInt, but you need to specify the random number can be generated within what number, upper bound. Means generate random numbers in the range of 0 to upper bound minus 1. Suppose if I give nextInt of 100, what does it do? It generates a random number from 0 to what, 0 to your 99. If I give integer, if I give next float, it will generate the random number from what 0.0 to 99.00. Next double means same thing, double between what 0.0 to 1%. And again here I'm just using a method for calculating the time taken, and the method what I'm using is system.nanotime. So observe here, system S capital, and you are taking the input from your system. That's it. Dot nano time is a method. What this nano time method will do is T capital. So this method returns the current value of the system timer in what nanoseconds. So whenever you initialize this method, whenever you call this particular function, what does it do? It returns whatever the current value in your system time is there, that will be specified in terms of what nanoseconds. And again, to initialize this particular random class, you need to import your random package. So import java.util.random. R should be in uppercase. Hope you're clear with this. So this is your program. We'll check how exactly your program will work. Okay, I'll just straight away go with your Eclipse and I'll run and shoot. Second. Yeah, coming back to your program. As shown that like I want to use your random class, I have included this package import java.util.random. Okay, now class have created quick. Okay, and I'm initializing a variable called as max and initialized value called as what 2000. And what in by static is a thing, but this value doesn't change it. And as you know that you need to call your partition function. For your partition function, I'm passing how many arguments? There are 3 arguments. One is your array, and you need 2 indexes. One is your low, and one more is what? High. And the low is pointing to which one? Okay, that is pointing to which one here? The second element. That's what, see, you're taking 2 variables, right? I and j. Okay, I will be pointing to your low plus 1. J will be pointing to what? The high, the last element. And the pivot element, whatever it is, that is your first element. That's why A of low, that has been assigned to what? Pivot element. So I'm taking 3 variables, pivot element and 2 indexes, I and j. And one more temp I'm using, that is used for swap. So I'm just using while loop. Okay, repeatedly check while low is less than high. Means if there are multiple elements, if single element, stop, come out, that's it. So as I said that I will be incremented until you find what? Until the element that is larger than or equal to pivot. If it is lesser, what you'll do? You can keep on incrementing your I value. How much time the I value will be incremented? Until you reach what? The end of your array. Until you reach the end of your array. Once you reach the end of your array, stop. No more elements are there. That's why I is less than I. That's it. Hope you're clear. Until that, keep on incrementing the I value. And whenever you find greater element, you stop. And next you go with your j index. So decrement your j until you find what? Smaller element. If A for your j is greater than pivot, keep on decrementing. So whenever you get lesser, stop. After that, I want you to check with your I and j index. If I is less than j, means I index is less than j, what I need to do is I need to swap what? I need to swap your A of I and A of j. I need to swap what? A of I and I of j. So A of I is copied to temp array. A of j is copied to which one? A of I array. Temp is copied to what? Whatever A of I is copied to what? A of j. If not, if j crosses, if the j index crosses your I index, I need to swap what? I need to swap your A of j array with what? Pivot element. Pivot element is pointing to which one? A of low. Pivot element is pointing to which one? A of low. So I'm just swapping it. So A of low is copied to temp. A of j up is copied to A of low, and temp whatever it is that is copied to A of j. And I need to return what? The j pointer. Means j pointer means that is your partition level. That is the partition index. That is your pivot element placed at your right position. The left will be your the element that is towards left will be what? The elements there's your left subarray that will be lesser than what your pivot element. The elements towards right of your j, whatever it is, that's your right subarray, it will be greater than what? Your pivot element. So this j will be sent to which one here? This j will be sent to your partition. Hope you are clear with this. So again, so whenever you do that, what happens is here. So partition method A low high. So here whenever you get 2 subarrays, A low will be pointing the first element, S minus 1. So you are retaining J is returned your partition. So S minus 1 means before the element of your pivot. And next the right subarray. You need to consider from what? after your j pointer, after your pivot element, so s plus 1, that will become low, and the high will be what? The end of your. That's it. This is for recursion call. And low is less than high, as if the more elements you need to check that. Hope you're clear with this. Now coming to your main function. Okay. I'm just taking your A array, I index. I need to specify what is your size of your array, how many elements you want to read. As I'm reading from your keyboard, I'm using what? Scanner class. Okay, and the number of integer is of what type? Integer. So I'm using next int method that reads what? The integer values. That's it. Hope you're clear. And I'm initializing your array. You know what is the size of your array is? Max have declared 2000. Means maximum number of elements it can be what? 2000. That's it. And as I said that whatever the elements I want to read, either I can read from file or I can use what? Random function. So for using random function, I need to use random class. R should be capital, and this is your object, new keyword, and this is your construct. Hope you're clear. I need to read n elements, right? So I'm using your for loop, n elements, for loop I'm using until what? Until whatever the number of elements you are specified. A of I equal to, I need to specify, right? The method, next int method. So it says that 20 means I need to generate a random number within what? Within 20. And how I can use this particular method with your random object, that is your generator dot next int. So what this will do is it generates a random number of n elements within what? Within 20, and it is stored in which one? Yeah, A of I. That's it. Hope you are clear. And I'm just printing array before sorting in your A of I array, and I need to note down the start time, right? So for that, what I'm doing is I'm using system.nanotime. So already I explained with this particular thing, system.nanotime, whatever it is. This method, what does it do? It returns the current value of the system. Current value of the system in what? Nanoseconds here. Returns the current value of the running Java virtual machine of the time source in which one here? Nanoseconds. That's it. Hope you're clear. Getting or not? So here that's it. I'm storing it in a variable called as start time. And I'm just calling a sort function. So when I want to call a sort function or a sort method, I need to call this through what? Class object. What's your class name? Quick. And I'm creating an object called as m new.quick construct. Constructor is used to initialize what? An object. Okay. So here, what's the function I'm calling is sort function. How I can call this? Through your class object. So m.sort is equal to what parameters I'm passing is A array, low, and j. See, low array is pointing to which one? Here 0, and high array is pointing to which one? Here n minus 1. If I give 5 elements, it will be pointing from what? 0 to 4. Pivot element will be 0, low will be your 1 index, and high will be what? Your 4. That's it. Hope you're clear. After sorting, I'll store that array, right? So once the sort is been done, I'm again calculating the time, and that is stored in which variable? Stop time. And in order to calculate how much time it has taken, so stop time minus what? Start time. So I'm just storing it in what? A particular variable called as elapsed time. The data type I'm taking is long. I may get more than the bytes, whatever it is. That's so I'm printing the time taken to sort array is plus where it is stored in a variable called as elapsed time. I'm printing. That's it. Hope you're clear. So I'll just run this program. You can just check it out. I'm just giving array elements as 10. What happens is 10 random numbers will be generated within what? Within a specified 20. Within 20 number, 10 random numbers are generated. 11, 10, 7, 14, 7, 9. And it prints how much time it has taken is 28,300 nanosecond. And sorted array it prints 377. Same elements it can pick, but within what? Within 28 picks. So sorted element is this. So for 10 elements, it is taking how much here? 28,300 nanoseconds. So let me increase the value. I said you read some 3 elements. I'm just giving 20. 20 elements is been taken and see sorted. And the time it is taking is 68,900 seconds. So next I will take something 30 elements. So here the time how much it takes is 50,800. So by this what I can say is as the number of element increases, the time taken to sort also will be increased. So that's why the time complexity, the best time complexity, whatever it is there, that is 0. n log n. Okay. So for that, you need to plot your graph, right? You need to plot your graph. So for that, what you're doing is, yeah, to plot your graph, okay, you write down the table and you read some different elements of different sizes. See, I'll take number of elements first. I gave 10,000. So 10 elements I've given, and time taken to sort something I got 28,300. I just gave 20 elements, and sorted element I took something 38,300, and I gave number of elements is 30 and something I got. So I need to plot the graph for this, right? So I'm just taking the graph for your x-axis, whatever it is there, that is your number of elements. I'm just writing 10, 20, 30, or you can give whatever the elements you give. Either it can be 5 or 10, 15, whatever it is. And the y-axis, whatever it is there, I'm just specifying what time in nanoseconds. Okay. And I need to specify one unit is equal to 1 centimeter is equal to how many units. So here, number of elements are just include 10 units, right? Here, x-axis is equal to 1 centimeter equal to how much here? 10 units. Y-axis, okay, again 1 centimeter is equal to what? How many seconds gap I've given? 1,273, 1,463, something. 2,000 nanoseconds. Y-axis what here? 2,000 nanoseconds. For 10 elements, it takes how much? 1,273. Next, for 20 elements, here it should be there. For 20 elements, something like 1,460. For 30 elements, something 1,683. And you can just see the curve, whatever it is there, it will be somewhat linear as n log n. As the time increase, as the number of element increases, even the time taken to sort also increases. So something instead of straight line, what it will be curved. That's n log n is the time complexity for what your quick sort. Hope you're clear with this, guys. So this is your quick sort program. Hope you understood. Okay, I'll stop here. Thank you.